All right, guys, so we are going to start our final unit here of the year. We're going to kind of get into a little bit of calculus here. So if you're taking some calculus next year, this will be kind of useful for you to have a little bit of an intro for it. If you're not taking calculus, it's okay. It still gives you a chance to think about some bigger ideas here in math. Now, I'm actually going to start with 9.2. I'm going to skip 9.1, but I'll call this, so this is really our first section of the unit, but I'm going to call it 9.2 so that it's consistent with what I was doing last year with my pre-cal classes. I'm just not going to do that section or that first section from last year. So we are actually going to talk about something today called the difference quotient, which really sounds really scary, but it's not as bad as you think. So I need to lay out a little bit of vocabulary for you here. First, my first thing that I want to show you, maybe you've heard of this in geometry, maybe not, something called a secant line. All a secant line is a line connecting 2 points along a function. Okay, a line connecting 2 points along a function. So, for example, if I had a function that looked, I don't know, something like this, okay, and I wanted to know what's the secant line look like between these 2 points. So it's literally just if I drew a straight line between those 2 points, that's the secant line. Okay. Now, a term that I'm not going to mention much right now, but you will see a ton of in calculus next year, and this is sort of the difference quotient sort of lends to the creation of this eventually, something called a tangent line. It's kind of hard to define a tangent line. I guess I can say it like this. It's the line created as the distance between 2 points on the secant line shrinks to 0. It's actually much easier to show this visually than it is to define it with a definition like I just did. So let me show you here. Let's see if I can replicate this similar function here as to what we just saw. So like if I was going to find the secant line between these 2 points, this is what it would look like. But if I were to start taking the distance between these 2 points and making it smaller, okay, we'll keep doing this in varying colors here. Okay, eventually we would get to a point that's along the graph where there's no more distance between those 2 points. And we have this line that just barely touches the edge of the graph. Okay, that's called a tangent line where it only touches the graph in one particular point. And the difference quotient lends to helping us find a lot of information with this tangent line. We're not going to go that in depth here with our intro to calculus here in pre-calculus, but the secant line lends itself to the idea of the tangent line, and all that's tied together with this idea of the difference quotient, which we're going to talk about right now. But anyways, so let's talk a little bit about the difference quotient. Okay. So what is the difference quotient? Well, I mentioned it a couple of times so far, but what the difference quotient is it's the slope of the secant line. Okay, it's the slope of the secant line. So if I go back right here, the difference quotient would help me find, every line has basically two key pieces of information about a line is its slope and its y-intercept. And so in this case, we could see that this secant line has a positive slope because it's moving upward. The difference quotient will actually help me figure out what this rise over run is. Okay. And to help us illustrate the difference quotient, let's go ahead. I'll actually go back again, just redraw that same picture that we had on the last page. So if I was going to find the difference quotient between these 2 points right here, I wanted to find that slope. What I'm going to do here is I'm going to give some arbitrary names to this. So let's say that this was at an x value of, well, let's just call it x. And then let's say that I moved a distance of, let's call it h in this direction to get to this point, okay? And just logical thinking here says if I start at x and then I add h, well, this x value right here is going to be x plus h, okay? Like if I started at 3 and then I went a distance of 2, well, then this new x value right here would be 3 plus 2, okay? So I'm doing that with numbers, except in this case, I'm trying to leave it arbitrary and I'm just using variables to account for those distances. All right, so if I knew that this x value was x and I knew that this function was f of x, well, then the way that I would find the coordinates of this point is I would say, okay, well, I have an x value of x, and I'm going to plug in that x value to find the y value. So we could say that point can be described as x comma f of x, which means this point right here has an x value of x plus h. So if I wanted to find its y value, well, I would do f of x plus h, okay? So I've got a couple different points here. I've got this point, I've got this point, and the difference quotient helps me find the slope between these 2 points, okay? Now, if we go back even to the most basic levels of pre-algebra or algebra 1, this is why I say the difference quotient sounds intimidating, but it's not really intimidating at all. We know how to find slope, okay? And its most basic form, slope is y2 minus y1 over x2 minus x1, okay? It's the change in y values divided by the change in x values, also known as rise over run, okay? So if we were going to use this with these values that we've come up with, we're just giving it a little bit, making it a little bit more fancy, because instead of using, x1, y1, y2, all that stuff, we're using x and x plus h, okay? So I'm going to go ahead and let's call this difference quotient. Okay, and let's think about what this would look like. Okay, so for y2 minus y1, let's go ahead and start out with f of x plus h. There's y2 minus y1 is f of x divided by x2, which would be x plus h, minus x1, which would be x. Okay, so we're almost done here with the difference quotient. The only thing is, if there's anything that we can get rid of, we'd want to get rid of it. And we can see on the bottom here, we have an x minus x. Those go ahead and cancel out, which leaves us with, and I'll always abbreviate this as dq for the difference quotient. This leaves us with f of x plus h minus f of x, all divided by h. Okay, so this is our difference quotient, and what it helps us do is it helps us find the slope between any 2 points along a function, and we call the line between those 2 points the secant line. So this difference quotient will help us find the slope of a secant line on a function. Okay. All right. So, and understanding the concept of this is also honestly the most important part of today. We are going to do a few different calculations with it. The calculation parts are just straight up algebra. It's really understanding what you're doing when you do that calculation is the important part, which is what we're laying out right here. All right, so let's go ahead and jump right into an example. For this example, when we're done, I will use, I'll do some follow-up stuff with it so you can kind of see what you've just found. But let's go ahead and find it first. So directions here is we are going to calculate the difference quotient. Okay, or in other words, can we come up with a formula that would help us find the slope between any 2 points along the function if we drew a secant line. Okay, so our function is, we're starting out with an easy one here. F of x equals 4x squared. Okay, so let's go ahead and write down the difference quotient again. Difference quotient is f of x plus h minus f of x, all divided by h. I'm just getting that straight from what we just found on the last slide. But now I need to actually start using this in relation to the function that we have. Okay. So if you recall from Algebra 2 and a little bit of Precalculus earlier this year, if you're going to do something like f of x plus h, this is called function composition. What this means is we're going to go to the function, which is 4 times something squared, okay? In this case, f of x is 4x squared, but since we're doing f of x plus h, this means in place of x, I'm going to literally plug in x plus h, okay? We'll do a little bit more with this in just a second. Minus f of x, well, we already know f of x is 4x squared, all divided by h. Okay, and from here, the rest of this is just algebraic calculation, making sure that you know what you're supposed to do with various exponents and so on and so forth. One thing that you definitely are not allowed to do here is x plus h squared is not equal to x squared plus h squared. Okay, do not ever do that. That is horrible math. You are now in pre-calculus. Don't ever do that. Okay, you know that when you do x plus h squared, you need to write this as x plus h times x plus h, and then you need to FOIL this out. Okay, so this would be x times x is x squared, x times h is xh, h times x is also xh, and then h times h is h squared. Okay, and we have some like terms in the middle here that we can combine, so we get x squared plus 2xh plus h squared. Okay, so I'm going to go ahead and let's use that here. So we'll have 4 times x squared plus 2xh plus h squared minus 4x squared. We'll need to do some distributing here in a second with this 4, all divided by h. Okay, so let's go ahead and do that. We've got 4x squared plus 8xh plus 4h squared minus 4x squared, all divided by h. Okay, let's see if there's anything that we can subtract out here. We got a 4x squared minus 4x squared. Those will go away. Take a look at what you've got left here. 8xh plus 4h squared up on top. Both of these have an h. Okay, this will be a common theme on all three of the examples that we'll see here. Once you get to this step, you can factor out an h on top, and what you'll be left with is 8x plus 4h, because one of these h's goes away, so it's no longer squared, all divided by h, and when we're done, we get 8x plus 4h. Okay, cannot do anything else with this, so this is my difference quotient for this function. Okay, now I want to look a little bit at this difference quotient, so I'm going to go here to this next slide. This difference quotient for us is 8x plus 4h. Okay, and if we think about our function itself, our function is 4x squared. Okay, and just to kind of draw a picture here of this function, this would be a parabola, a very skinny parabola. Okay, but it would have a shape that's like this. Okay, so I want to just talk about a couple of different things here. Let's say I wanted to find the slope, the secant line between x equals 1 and x equals 3. Okay, I'm going to show you this in two different ways. So let's just say, for example, this is x equals 1 and this is x equals 3. Okay, as we can see from this graph, it's not perfectly drawn, but our slope would definitely be positive. Okay, we can see that this is a line that's moving up, so it's going to have a positive slope. Okay, let's say we were going to try to do this with the difference quotient. Okay, let's do this with the difference quotient. All right, now a couple things that we're going to need for our difference quotient. So we've got 8x plus 4h. We need an x value, and we also need an h value. Okay, well, I got a couple different x values that I can choose from. I can choose x equals 1, or I can choose x equals 3. I'll actually do it in both ways here, but let's try x equals 1. So if I was going to use x equals 1, to find the difference quotient, I would plug in 1 for x, but then I would also need an h value. Okay, now if you remember from my explanation here of the difference quotient, my h value is the distance from one x value to the next x value. Okay, so, and this h value is what you add to get from the first x value to the next x value. So in this case, if I'm going from 1 to 3, then that means my h value is 2, okay? Because I have to do 1 plus 2 to get to 3. So if I plug in 2 right here, I get 8 plus 8, and that means that the slope of this secant line right here needs to be, use the letter m to represent slope, the slope would be 16, okay? Now, if you wanted to try this in reverse, So let me start out with 8x plus 4h again. Let's say this time, instead of using an x value of 1, you wanted to use an x value of 3. Well, this would be fine. But what would change here? Well, the h value would change, okay? Because this time, I'm not starting at 1 and adding to get to 3. I'm starting at 3 and I'm subtracting to get to 1, which means that instead of having an h value of 2, if I'm going to use an x value of 3, if x equals 3, then h would actually have to equal -2 for me, because I'm going backwards 2 instead of forwards 2. Okay, but no worries if you think about this and do the math. 8 times 3 is 24, and 4 times -2 is -8. 24 minus 8, once again, we get a slope of 16 for that line. Okay, now just to bring this back to what you guys learned in pre-algebra and algebra 1. Okay, now obviously we're doing this with a pretty simple function right here. This is not always going to be the easiest way to do these problems, but the difference quotient typically ends up being the easiest way, because using what you've learned in algebra 1 and algebra 2 and pre-algebra sometimes is not the simplest of calculations. But if you did want to do this by just using old-fashioned slope, doing y2 minus y1 over x2 minus x1, well, you would need to figure out y values for both of these points, okay? So let's see, if I tried an x value of 1, if I went up here to this function and plugged in 1, I'd get 4 times 1 squared. 4 times 1 is 4. Okay, and then if I used an x value of 3, well, 3 squared is 9. 9 times 4 is 36. If I used this slope here, I would do y2, which is 36, minus y1, which is 4, divided by x2, which is 3, minus x1, which is 1. 36 minus 4 is 32. 3 minus 1 is 2. 32 divided by 2. Once again, we get this slope of 16 between those 2 points. Okay, so what I'm showing you here is no matter how you slice it, whether you use the difference quotient or whether you use old-fashioned calculation for slope, you are going to get a slope of 16 between those 2 points. The difference quotient lends itself better to being able to actually do calculus. We're just laying the very, very basic groundworks of it right now, which is why it might seem easier for you to just use old-fashioned way of doing slope, but in reality, with higher level calculations, the difference quotient is more effective for us. But I'm only using this example so that I can show you how all of these things relate, okay? All right, a couple more examples. These are not any different than the first one, just a little bit more advanced, if you will. Let's go ahead and try. Once again, we're going to calculate the difference quotient, but with a different function this time. Let's try it. And I won't do all that stuff at the end like I did on the last one. We'll just find the difference quotient and then we'll be done. But let's try it for this. F of x equals 9 minus 1/2 x squared. Okay. I always like to start by just straight up writing down the difference quotient first and then starting to plug in stuff from there. So here's our difference quotient. If I do f of x plus h, that means go to my function, which is this. 9 minus 1/2 times something squared. And in place of that something, I'm going to plug in x plus h. Okay, minus my f of x is, now this is really important. If I'm going to plug this function in for f of x, I must put parentheses. Okay, sorry, I wrote brackets. Doesn't matter if you use brackets or parentheses. I'll go ahead and use parentheses. So this will be minus 9 minus 1/2 x squared. This is f of x, all divided by h. Okay, and again, like I mentioned on the last problem, the rest of this is just algebra. You must be able to do this type of algebra in order to complete this problem. So we'll have 9 minus 1/2. We already expanded this out on the last problem, so we'll use what we got on that one. X squared plus 2xh plus h squared. Okay, we'll go ahead and distribute this negative sign, so this will be minus 9 plus 1/2 x squared all over h. Okay, moving down to this next line, we'll go ahead and distribute this negative 1/2, so I'll have minus 1/2 x squared minus xh, half of 2 is 1. minus 1/2 h squared minus 9 plus 1/2 x squared, all divided by h. See if anything cancels out. In this case, the 9's cancel. And also the negative 1/2 x squared and the positive 1/2 x squared cancel. And as I mentioned on the last problem, take a look at this step. Okay, both of these have an h. So I'm going to go ahead and factor out that h. And I'm left with negative x minus 1/2 h, all divided by h. And you will always see this every time you're calculating a difference quotient by hand like this. These h's cancel out. Top and bottom, you can divide them out. And when I'm done, I'm left with negative x minus 1/2 h. Okay, so again, we come up with a formula that would help us determine the slope between any 2 points along the secant line for this function. Okay. All right, one more. Again, just another a little bit more advanced calculation, and then we'll be done with this video, and I'll put up an assignment for you guys to practice. Only like 3 or 4 of these. I'm not trying to do anything too crazy with this. Just want you to try a few of them, see if you can do them on your own. So once again, we'll calculate the difference quotient. And for our function this time, let's do f of x equals, we'll try 2x squared plus 2x minus 5. Okay. And difference quotient again, just writing it down here, f of x plus h minus f of x divided by h. Okay. Now, if you're looking at this function, one thing that makes this one a little bit trickier than the first two that we've done is that x, the variable x, actually shows up in a couple different places here. It shows up here and here. Okay, that's okay. It just means your calculation is going to be a little bit longer. So let's go ahead and try it. So f of x plus h, if we go to f of x, that f of x is 2 times something squared plus 2 times something minus 5. Okay, in place of that something, I'm going to plug in x plus h. Okay, this is me writing out f of x plus h. Okay, now we need to subtract f of x. Remember from the last problem, you must put this inside of parentheses so that you distribute the negative. So this will be 2x squared plus 2x minus 5, all divided by h. Okay, a lot of algebra on this one, so please be careful as you're working it out. Okay. All right, we already know x plus h squared is x squared plus 2xh plus h squared. Okay, I'm going to go ahead and distribute this 2 right here, so we'll have plus 2x plus 2h minus 5. Distribute this negative, minus 2x squared minus 2x plus 5, all divided by h. Okay, let's go ahead and distribute this 2. Sorry, I guess you could go back if you'd like to. You can go ahead and cancel some things because I realize I'm going to run out of space. Just off of this step, 2x, negative 2x will cancel. Negative 5, positive 5, those will cancel. So I'm going to go ahead and only write down what's left here. So plus 2h minus 2x squared, all divided by h. Okay, as I've mentioned, these will also cancel out, and look at what's left over. I have a 4xh plus 2h squared plus 2h, and just like on the first examples that we've seen, all of these terms have an h. So if I'd like to, I can factor out that h. I'm left with h times 4x plus 2h plus 2, all divided by h. Cancel out those h's. When I'm finished, my final difference quotient is 4x plus 2h plus 2. Okay? So we see some of the algebra involved in calculating these difference quotients. And again, when I do this, what I'm doing is giving myself a formula to find the slope. If I were to draw any secant line, or to draw the secant line between any 2 points along the function, this is a formula to help me figure out the slope of that secant line. Okay, it's one of the most uh, foundational things when it comes to calculus and understanding some of the bigger ideas that you'll learn if you ever take calculus. So we're just laying the very, very groundwork of that right now. And if you move on to higher level math, you'll see a lot more of this. Okay, that's all I've got for now, guys. I will talk to you later. Bye.